all of you. I'm Derek Ham, and I'm the SIGGRAPH 2022 Immersive Pavilion Chair. I'm also the Department Head of Art and Design at North Carolina State University's College of Design. And when we look at the VR and mixed reality landscape, it's rapidly changing. In fact, it might be safe to say that change is the only constant for those of us working and doing research in immersive technology. As we count down to SIGGRAPH 2022 in Vancouver, in person, not in these little squares that we're here right now, I'm thrilled to moderate this discussion with the team behind one of our Immersive Pavilion selections, Mixed Reality Collaboration for Complementary Work Styles. This project combines immersive VR, multi-touch AR, real-time volumetric capture, robotically actuated tangible interfaces at multiple scales, spatial audio, live coding in the service of a human-centric way of collaborating, all of this put together in a fantastic way. Participants bring their own unique talents and preferences to tackle complex problems together in a shared mixed reality world. I hope today inspires you and that this deep dive into SIGGRAPH 2022 selection excites you about what you can expect at the experience in Vancouver and online. So without further ado, I'd like to invite today's guests to introduce themselves and share even more about mixed reality collaboration for contemporary work styles. Panelists, please.
Carrie, you want to go first?
Yeah. Hello, I'm Karu. I recently graduated from NYU with majors in interactive media arts and computer science, and I'll be joining Professor Ken Perlin's Future Reality Lab as a PhD student in September. And my research interests are human-computer interaction, VR, AR, tangibles, basically how to connect the virtual world with our physical reality. Nice to meet you here.
Great. Zhu?
Hi, my name is Zhu Wang. I'm a postdoc researcher with Ken in the lab, and I also graduated from the Future Reality Lab as a PhD student. So I'm happy to be here and working with my colleagues on this project. And basically, my research interest is VR-based interaction, machine learning, and human balance related assessment and rehabilitation system.
Thank you. Carl?
Hi, I'm Carl Rosenberg. I'm a current PhD student with Ken at the NYU Future Reality Lab. And my interests are broadly human-computer interaction, and in particular, multimodal interfaces and creative support tools and applications. Pleasure to be here.
All right, Stephen?
Hello, everyone. My name is Stephen Yu. I'm an assistant research scientist and also a developer at the Future Reality Lab under Dr. Ken Perlin. My research area is going through the emotional recognition in VR and immersive environments and looking at the biofeedback relationship between the visual and the audio. Nice to meet you, everyone.
Thanks. And I'm Ken Perlin, a professor of computer science at NYU. I direct the Future Reality Lab, and my interests are helping my students with their interests.
That's fantastic. So we're looking forward to seeing a live demo of your project in Vancouver for this year's SIGGRAPH 2022. But before we dive into our conversation, I would love if you would be willing to share a teaser of your webinar to our participants who are joining us online right now.
Karu is going to cue that up.
Yeah, let me share our teaser.
Hi, I'm Ken Perlin from the NYU Future Reality Lab, and I'm here to talk about our submission to the SIGGRAPH 2022 Immersive Pavilion. Not everybody is the same. People have different styles of working. People think differently from each other. One person might want to solve a problem by looking at it as a miniature in front of them that they can move around. Another person might think with their whole body. Maybe they want to be in an entire space and work things out that way. Yet another person might be a programmer. They want to write algorithms and change code in order to express what they're trying to say. None of these people is wrong. Each way of working is perfectly valid. And in fact, there are some kinds of problems that require these many different ways of working for collaborators to bring together, each bringing their own special sauce. Our submission this year is a solution to this problem, where we use such technologies as mixed reality, active tangibles, virtual reality, volumetric capture, and robots at different scales to allow people to solve the same problems collaboratively in a way that suits the individual problem-solving style of each person. Thank you.
Wow, thanks for sharing that teaser. I'm very excited. I've seen this several times. Every time I see it, I personally can't wait to meet you in Vancouver and get my hands on it and check out the functionality for myself. And I'm sure several of the attendees, just seeing that, probably their wheels are spinning and they have lots of questions. For those who are online, please, I remind you to use the Zoom Q&A function to submit your questions for the panelists. If you don't have any specific questions, you can upvote someone else's by liking it with the Q&A window. And we'll put those in around the 45-minute mark. But let's start by discussing the inspiration behind the mixed reality collaboration. How did you identify the need for this type of collaboration, for the use of technology this way?
Things that used to be really, really difficult become easier, and then they become taken for granted, and then we forget that they're technology. What is it, that old saying, technology is anything that was invented before you were born? So we're all walking around with Captain Kirk's communicator in our pockets, but we don't think about it. And a number of things have been advancing. Some things, unfortunately, had been forced to be advanced because of the pandemic. So, I have collaborators that I meet with almost every day who live on the other side of the world. And so there really is a need to mix the physical and the virtual. And one of the things that's happened with, for example, Zoom, is that we've had this opportunity to meet with people, but we're all just staring at people on screens. I can't really establish eye contact. We've lost the physical aspect of things. And so we were thinking, as other people have thought, we'd like to bring people back into their bodies. We'd like people to not just be staring at screens, but be moving around. And while we're doing that, we can start also thinking about superpowers. Like, I read Harry Potter. Why not be able to have magic? And as long as you're starting to embrace technology. So we start thinking about things like, hey, I can walk around in a world and there's physical proxies for things in my mixed reality, but somebody else could be looking down and seeing that same world as a miniature on a table. And these are things that we weren't thinking about before we were all forced in 2020 to start going virtual. But now we can say, let's look into the future. Let's look at a better physical, a more exciting and more a physical with greater powers. And it was really the inspiration for what all of these students are putting together.
Fantastic. Now, when you talk about these items, let's review this again. You have multi-touch AR, you have immersive VR, real-time volumetric capture, robotically actuated tangible interfaces, spatial audio, there's so much going on. And for our listeners, maybe you can give us just a little bit of the technical aspects of how are you bringing all these technologies together?
Well, mostly we just really wanted you to have to go through a long list. We've obviously succeeded. We're a research lab. So a lot of what we're trying to do here is, we're not trying to make a specific product. We're trying to understand what can work well and which means we don't want to do things just one way. We want to do things many ways and then do research comparing them. So what you're seeing right now is we're building a laboratory that says, does this work better in physical proximity? Does this work better when you're online? Is this work better when you're in miniature scale, at full scale? What's the importance of haptics and touch? What's the importance of spatial audio? So there are many, many research questions that we're gearing up to ask. And what you're seeing here is a demo of what you can have in a laboratory that then allows you to start asking these questions about the future of human-computer interaction. And I'll leave it up to the students to start talking about either some specific technical things that they think they needed to work especially hard on, or if there's specific questions that they themselves are interested in. Feel free to jump in. Yes,
okay. I can give you an overview about our technical aspect. So the technologies we bring together include full body motion capture using Vibe Tracker or OptiTrack system, WebXR-based VR for multiple users, Unity-based AR with slime tracking that allows the user to peek into our virtual world and interact with multi-touch interface. And also we have a low latency network to connect all the components together. We also have parallel tangible interface at full and miniature scale. They are implemented as swarms of mini desktop robots and large robotic cars, and they will move the physical proxy to the user's fingertips when they are interacting with our virtual content for haptic feedback. Speaking of challenges we have in development, I think one of our biggest challenges is that in the physical world, there are many constraints, but it is not true in the virtual world. We actually have some challenges in synchronizing the active tangibles on different scales. So we have two kinds of tangibles, the small robots that user can directly manipulate their position with their hands, and the larger robotic car whose position match the tiny robot to a larger scale. The change in the tiny robot can happen really quick, but it takes time for the larger robot to move to their position. And there are many constraints caused by things such as the motor speed and the maximum loading capacity. So we spent some time finding the right hardware and tweaking our algorithm to make the whole experience as smooth as possible. Also, building the network to connect all those platforms together is also quite challenging.
Yeah, you talked about some of these challenges, and one that comes to my mind is any type of lag in time, latency. Can you talk a little bit about any things that come to your mind that you had to overcome, such as latency or other things that we're probably not even thinking about, that you're like, man, that was a thing that we threw on the whiteboard for weeks to try to figure out, like that one little issue? Are there certain things that come to mind?
Well, I think for our experience, we are trying to give the user haptic feedback when they're reaching to the virtual content. But for the virtual content, their position and their orientation change can happen in a sudden, because everything in the virtual world does not follow the physical rules. But to map the physical content to that virtual object, you might need to apply some mapping algorithm and things like that in order to overcome the latency that will influence the user's feeling of immersion.
And also, if a person is reaching for an object that they think is somewhere, you have a certain amount of time. You can show the object there immediately. But meanwhile, because it takes some physical time to reach toward that, you have a little bit of time to move the physical proxy into place. And we use that to make sure that by the time they make contact, the physical proxy is in the same place as what they were already seeing.
Wow, that's really insightful. I want to talk about another component that I see here in your description, and this idea of human-centric way of collaboration. Can you unpack that just a little bit? What do we mean when you're talking about people forward? And then also, even related to that, are there certain industries where you see this really being essential today to kind of use this approach to designing solutions for them as opposed to others?
Well, one of the things that ends up happening with any technology when it's very new is that, oh, wow, we can do this thing we could never do before. And so you get these sort of awkward growing pains Like, well, I guess we never had telecommunications. So, we had to start with telephone booths because that was the only thing we could do, or people had to crank up their cars. So I mean, and there are plenty of things like that with computers. Everybody had to sort of learn these very difficult, arcane ways of doing things in the early days of the computer, of the internet, of even smartphones. So as technology advances, and as you also have machine learning that allows an understanding of a modeling of what people do, then you go from these I mean, you all remember the early days of, speech to text and how they got it all wrong. And then they gradually started building better machine learning models of this is what people actually mean to say, and everything got better. And we're basically applying this to, we think these are early days for embodied haptic interfaces. I mean, the next decade is going to be very exciting. And we're trying to understand and anticipate once the technology gets off the screen and starts coming back into our physical world and just really becomes part of our everyday life with, I pick up my coffee cup, I look at you with eye contact, we use our bodies. How do we make best use of the capabilities of what's coming next to make everything about humans in their bodies socially interacting with each other? Not, sorry, I have to go stare at my phone or look at a screen all day.
What I love about the work that I love so many things about your work, but what I love about SIGGRAPH in large is that we're able to highlight projects like this and in a scholarly research way where even other labs could study what you're doing and duplicate and replicate. And that's how our knowledge grows. And Haru posted here in the text a question about your work in relation to other labs. And obviously we talk about precedents, we cite other work. He's mentioning the work of Alan Kay and Brett Victor's Dynamic Land. Maybe you can talk a little bit about how, when you started this project, who else were you kind of looking at and comparing research approaches to, and kind of being a part of this larger synergetically work and immersive collaboration?
Yeah, so actually, when we initiated the project, we have a few existing literatures that we have reviewed and want to compare with, and just want to talk a high level of the existing projects that we have been referring to. They are like using different scales to tackle some real world problems, like giants can do some like planning for the let's say floor planning, and some miniatures can do like something like in a very detailed level and check about some a smaller scale, something like a cave, to explore a smaller cave, which is not possible for the giants to look into. And other projects like restaurant floor planning and maybe stage planning, these are all similar scenarios that we have been referring to, and can be comparable to our scenarios. And regarding why we had this idea was because somatosensory information is actually a large portion of human perceptions. And in most of the VR system, there are some kind of a haptic feedback for the existing VR platform, but it's most of them are focusing on the algorithmic level, not for the physical proxy or can have a physical duplicate of the digital version of the world. But I think the beauty of the VR or mixed reality is not only limited to visual cues or auditory cues. They should expand to the physical somatosensory input that the human users can perceive. So that's why we always focus on the human-centric design. And users, and because humans prefer to work collaboratively rather than like a solo working. So I mean, for a better teamwork, it's better for this system to focus on a collaborative and interactive system. So each of our modules are self-contained. So we don't have to tweak parameters according to our colleagues, the settings changed by our colleagues. We just need to pass the parameters and with settled API for each others to deal with the parameters and the data. So for each of our system is self-contained and it's modularized. So for the design itself, it's a human-centric, and people with different inputs interface like tablet 2D or 3D inputs with a VR system, they all can use their natural interaction with devices they use. So that's generally what we are aiming for.
You know, I'm listening to you. This is so fantastic. And even as you're talking about human-centric, you're still using terms like being a giant or being small. And Ken's reference to Harry Potter, I laugh, like even my students often talk about moving through VR like port keys as a method to interact with things. But it seems like your lab like embraces language of fiction as well as citing other scholars. And then can I diverge there for a second and ask about how you know, is that an important thing for you all to like reference Star Trek and reference the magic of it in a playful way as you push the technology forward? You're muted, Ken.
Muted. I certainly have always been inspired by, I mean, I got into computer graphics because I saw Fantasia when I was a teenager. And I was like, okay, that's what I want to do. That's decided. And, you know, I mean, I think there's something really elegant about just the vision of the Jedi Council. It just says so much. Like you see it and you know immediately what's going on. Or conversely, the holodeck from, you know, the rival universe. And, you know, I mean, you know, I thought Jason Segel had it right in the Muppets movie. We should all travel by map. You know, it's like you read about these things and you're like, why not? Why not do what Harold and the Purple Crayon could do? I mean, because I don't think the greatest visions come from just the people who end up implementing them. I think they come from people who think more broadly about the human condition.
Wow. Maybe you can talk a little bit more about collaboration's impact on productivity, specifically for being in the workspace. And there's kind of like workspace morale, but how do you think these kind of mixed touch points of technology will just change? I don't want to get to that point of just pure metrics of businesses, like how productive are you? But maybe you can talk about its use case for productivity and work, or maybe the synthesis trying to learn how to bring up concepts, or what it does for collaboration, or talk to some very pinpoint examples of where you see this changing the workspace.
Kara, you had an interesting example that you told me about earlier today.
Yeah. So I think one of our user scenario I can imagine is using our system in collaboration, including spatial planning, such as stage design and theater. I'm going to take the stage design as an example. So usually there are several roles in a stage design team: director, lighting designer, stage manager, and the actor, and so on. Members, such as the stage manager, usually they prefer to work on their design on a larger scale, like how to arrange the environment and how to compose the sequence of steps for the actors, while actors usually prefer to immersively experience the whole stage. And the light designer will prefer to have an easy and precise control of the lighting direction, the brightness, and so on, which will be really easy to do with some sliders and multi-touch interfaces. So with our system, people like the stage manager can easily do their design viewing the whole stage and the actors as a miniature world on the table, and they can manipulate the environment directly with their hands. The actor can walk into their design in real time for our parallel full-scale world, and others, such as the lighting designer, can peek into that virtual stage and manipulate the lighting using multi-touch AR platforms such as the iPad. So this is one example, I think, that suits our system design really well. And it will also apply to other collaboration, including spatial planning, that the designer can plan the whole thing from a miniature world, while the people who experience that design can just walk into their design environment in real time, and they can all communicate together for a better solution.
Oh, that's beautiful. How about workplace morale? The technology in its nature is magical, is somewhat playful. Do you imagine that using this as a way of collaboration might even change the overall tone of a workforce or a workplace?
Yes, and as we can see, we're providing a different medium of technology, such as VR, physical, tangible, as well as live coding. And as humans, we need a physical proxies to have the interpersonal rapport, right? And then having that collaboration in the workspace will bring an interesting outcome when it comes to whether I'm looking when I'm in the VR headset and looking at the target and looking maybe I'm using the iPad to look around the spaces. So different perspective will bring a different set of good thing challenges as well as pros and cons. So it's for us as technicians and the programmers, we want to provide those tools, and then for designers and the storytellers will bring that interesting examples to find out that could be a research in its own. So yeah.
That's great. I'm going to remind all the attendees to please use the Q&A and start to drop your questions in as I continue to probe and get more information about what we'll be seeing. And back to the team here, can you tell the attendees what you're bringing to Vancouver? Jump in, like what headsets are you bringing? What hardware are you bringing? What will the experience be like? What we'll be able to touch and interact with?
So actually, what we are going to bring to Vancouver is the whole set of the system. So including motion capture. Regarding the motion capture, we initially use OptiTrack, which is a high accuracy and low latency. So it's one of the top of the line system that we can ever get. But the thing is that we are going to get a Vive system to Vancouver instead of OptiTrack. One thing is because we want people to try our system. That's one part. The other part is that we want people to easily replicate or reproduce what we have done for our research, because that is one of the core values of the research, which is reproducible. So I think the reason why we take an extra effort to make it into a version compatible with a Vive tracker was because Vive tracker is easy for people to get access to. And the second thing is it can convey the idea enough. So we don't have to use tens of thousands equipment to convey the idea. And the second is the robotic cars, robotic proxies. We are using robotic cars for the robotic proxy. Was the idea is to have a proxy in physics in physical world, so that when you are perceiving something in virtual world, in the digital world, you can as well feel it in the physical world. And so the headset we are going to bring is a Vive Pro Eye. Eye tracking is not a focus of our project, but so our lab has been using eye tracking a lot for our research, like online meeting and faster typing related projects, and also other equipment we are going to bring there is like a premium router, because our system heavily rely on a research network called Courant, which is a high speed and low latency research network we are going to use. And this is a glue to connect all of our modules together. Without the high-speed network, there could be like a latencies, because when we are doing some collaborative and interactive interactions, nobody wants to have that kind of delay.
And as you talk about the robotic systems, I want to push a little bit further and ask about the future with AI, machine learning, and as we start moving from human to human collaboration work, we start thinking about human to machine to other human collaboration. Do you think your system is helping to pave the way for those types of collaborative environments as well?
Definitely, I think so, because for the physical proxies, they are actually controlled by the system. So without proper self-adaptive motion planning, like pathfinding or autonomous driving, something like that, without the AI and machine learning, there will be a lot of extra effort that for the users to manipulate the virtual and physical objects. So I think that's one of the aspects that AI and machine learning can be very helpful. And another thing is that the virtual content, because VR content generation has always been like one of the issues that's preventing the VR goes to everyone, because it's like a simulator. So everything has to be simulated in the VR or MR world without sufficient content generation. It will break the connection between our perception and the virtual world. So our system, actually, we are developing some content generation, both on sketching and modeling. So our vision is that we are going to integrate the sketching and modeling system, data-driven sketching and modeling system into our collaborative system, so that users can easily just use their hand or maybe a controller to sketch an object or model an object in VR space.
I think it's also.
Yeah.
Sorry.
Continue. Yeah.
I wanted to just add and echo what we said earlier about superpowers. I think the great thing about AI and machine learning is also not necessarily treating them as agents of controlling things to work with, but also using them as like you're another tool in the tool shed, like giving you the ability to control things with, I don't know, speech, or being able to generate content that looks like it's part of a conversation with somebody else, or getting sort of suggestions from the system for what sort of content to make, not necessarily treating them as agents. So there's a lot of kind of vectors of exploration when it comes to what a machine learning system is and what affordances it can give you. And our system can support that sort of thing because of its very like plug-in architecture sort of foundation that we've been working on.
Just to amplify what Carl said, so if you move away from the whole Star Wars R2-D2 C3PO, robot from Lost in Space, and you instead say, let's think of AI the way we think of AI when I talk into my phone and I do speech to text. Well, so that's not like, oh, there is this sentient being, but it's rather a whole bunch of human behavior has been scraped into convolutional neural nets and now is available to us very efficiently. And we can apply this to many things. For example, if I want to hand you a cup of coffee and you're actually 1,000 miles away, well, there's going to be unavoidable latency, but a robot system can have learned this is how people hand a cup of coffee to somebody. So in that fraction of a second, the movement of my hand and the forces can be simulated, and you feel that I handed you a cup of coffee. You're not thinking, oh, there is an intelligence there. You're just having a natural interaction with me over a distance that you at one point could only have had if we were physically in the same room. But ideally, as Steven Spielberg once said, the best special effects are the ones you don't know are there. So this is kind of where we want to go with this. We want to have in the substrate of things, little bits of machine learning that allow us to express our humanness even over distance.
Wow. And certainly your mixed reality collaboration project is built in such seems like a modular way that can just expand to as you respond to technology that's being advanced. And Robert Ellis asked right here in the question, what technology potentially are you out there expecting or seeing that you might be a future node that you want to snap on? Are you looking at, for instance, smell or more advanced haptics, or what else is out there that you're like, hey, that might be something worth snapping on testing for the sake of mixed reality collaboration?
I could try to take a longer view on this one. So in 1999, Apple Computer snapped up a whole bunch of patents from a guy named Westerman, for multitouch. So starting in 1999, Apple had multitouch, even though it was invented by somebody else. 9 years later, they come out with the iPhone. So they basically were working on this for most of a decade. And of course, they waited because in 2008, you could actually put the web on a smartphone, and it was the right move. They needed for all the technologies to come together. A lot of what we're doing is in anticipation of, just like multitouch, things that aren't ready yet. And the reason is that we're still living in the primitive days of 2022 or 2023. And we're stuck with 5G. We're stuck with maybe a few gigabits per second. But meanwhile, other research is going on, some of it at NYU, some of it elsewhere, that's going to bring about 30 to 100 gigabits per second wirelessly, but that's going to take a decade. So a decade from now, when you put on your glasses, they're not going to have all the computation. It's not going to be like, an Android system with Snapdragon graphics from Qualcomm that can only do what a phone can do. You're going to be connected to the cloud, and you're going to have all of that power with very low latency. You can't have that today. It's kind of like trying to talk about digital television back in the 1970s. You could talk about it, but you couldn't have it because you say, what will the world be like? There was Negroponte's law, which he said back in '86, that in the future, telephones will become wireless and televisions will plug in. And he was absolutely right, because he said, what happens with Moore's law? So if you look 10 years in the future and everybody's got essentially unlimited bandwidth to their glasses, that's a world where a lot of what we're doing starts to become just practical every day. Nobody thinks about it. It's like turning on the faucet and the water comes out. So we're trying to think about that future, even though it's not a future that consumers can experience now, because somebody has to start thinking about that, just as Apple started thinking about multitouch in the late 90s.
Wow. There's a question from the student perspective and angle, and I'll add to this about this question about, well, how do students even start to get into VR mixed reality? And maybe you can more explicitly just talk about, for some of the students, what was your undergrad experience like? How did you enter into the lab? What was your background, or the thing that said, that is what I want to do more of? What was your version of Ken's going to see Fantasia? What was your kind of, that's it, and I need to work in that space?
I don't think this is a question for me.
Right.
You guys take it.
Yeah, I think my personal opinion about what they need in order to do VR or AR or XR related stuff is the equipment, the algorithm are not the critical part. I think the critical part is what they think or what they dream. I mean, all of this VR and AR stuff has been envisioned by pioneers decades ago. And so maybe one of the good examples is the Matrix movie. I mean, when I was little and watched that movie, I don't even know what the movie was talking about. But nowadays, I mean, I believe that most of people will believe that is a future, maybe in decades or maybe in 100 years later, that would be the truth, because VR, XR, AR is more like a simulator. So, and the matrix is a big simulator. So I think the idea is that when everything is so realistic that people cannot tell which is true, which is physical, that is the future of VR and AR. So what important here is what we dream. So if we can dream that we are being one of the like simulator world like that, how can you contribute to that world? It's not like what the world requires you to do. It's more like how you push forward and make it accelerate the coming of that future.
I agree with, oh, you go.
Oh, sorry. Thank you. I would like to add on my perspective as a student and give advice to who wants to go into virtual reality or augmented reality or mixed reality. I think everyone here in the lab mostly started with the computer science background, like a coding and machine learning, AI. That's the first term, few buzzwords that people hear about it, right? And that's the really hot topics, right? And then virtual reality and the mixed realities are emerging, and it's a new pioneer field, right? And as a growing up, and I think most people agree, growing up with the movies and medias, I grew up. My first iteration of virtual reality is a Nintendo Virtual Boy from 1995. I thought that was awesome. Obviously, from that Virtual Boy to current top-notch version that we have for virtual reality, the technology has advanced massively, right? So my advice is, so my take on this is you need to have a creative mindset as well as the fundamental programming aspects as well. And my tips for students who want to start virtual reality education, I would highly advise to go into game programming or game designing, because for us as a research group, and this project is all about collaboration and mixed reality, right? And then all the inspiration that our work is mostly from Dr. Ken Perlin's Fantasia and other Jedi Councils, right? That's the pioneer and the initial work that it's spread it out that we're able to create this system, right? So basically, we're creating each modules. Maybe we'll have a Jedi Council module or a room. We'll have a Star Trek's the other other planets, right? So I think having that core mindset is a key. So that's my take on for incoming students.
I agree with Zhu and Stephen on the whole, where I think getting into VR is really more about having the creative mindset and creative ambition to come up with something new that fully leverages the medium and the technology, as contrasted with, for example, like if you just want to duplicate something in a window desktop UI and put it in VR without, like, what's your goal there? I think it's all about like pushing it forward. What's new? What could give you those superpowers we're talking about? Because if you don't have that drive, and it's not that it will be bad or that it'll waste your time. I mean, go ahead, sure, but like it's more interesting if you go into it with the mindset of like, let's do something nobody's thought of, and how will it help people in particular, solve particular problems, etc. So otherwise, I think everything will fall into place. I mean, the hardware is changing rapidly and the software is changing rapidly. So learning any one particular thing is cool, but it's not the main focus here. So yeah.
Yeah, I totally agree with Carl's point about that the hardware and the software could be outdated. I mean, when the young undergrad student or maybe even high school student want to learn something, and learning is not easy actually, but as long as they are comfortable to leave their comfort zone and have the capability and the time to learn, I think that there will be no problem, because for example, our system takes more than 10 technologies to make it happen, such as like networking and like API design and infrastructure design and motion capture, blah, 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 all of that, robotics and C++, Python, all of that. So, but I don't think it's feasible for all of the young students to learn all of this and make it happen. It's more like when you have the idea, when you have the dream that you want it to come true. So try to look for the pieces that is missing, and you can team up with the other collaborators who already has the skill sets and team up and try to build the world that you want to see. So my point is that you don't have to have all of the skill sets ready to be part of the world that you are trying to contribute to.
Yeah,
Okay,
I
Ruth?
totally agree. And actually, for me, my undergraduate actually started with arts. I was first majoring in interactive media arts, and to be honest, I'm really bad at programming at that time. But I think doing research, especially in human-computer interaction, is more about your idea, your creation, your imagination, other than your skill set. And actually, I find that doing art and doing research have a lot of similarity. They are both about like creating new experience and creating something playful and experimental, but maybe art focus more on asking question and expressing yourself, but research focus more on finding and question and answering them. So I think if you like if you're really creative and you have a lot of things like imagination going on in your head, then you don't need to be afraid, but be scared by the big word of research or computer science. You can just try and it will be really fun.
Wow. I want to talk really briefly about, the work that you're doing can really impact so many different industries. And, I would like to say, if you build it, they will come. And I know in my experience that has not always been the case. I previously have 2 degrees in architecture. And I remember I put on that first time my Riff DK1, I put it on. I was convinced the whole industry would immediately switch over and VR would be the #1 source where you'd be designing and creating buildings and cities. And it's 2022 and it's still not the industry standard for how construction is done. I zoom out and I ask, in your experience, have you found that there are certain industries that are more apt or even more excited and willing to start using systems that you propose and as you're proposing as their new future workspace environment and their new future way of collaborating than perhaps others?
Well, the first industries to use anything are the industries that have to. So, I mean, the first people at here at NYU that used virtual reality were the brain surgeons. It's like, hey, people are going to live, they're going to die. We don't even talking about how much money it's going to cost. We have to figure out the right route through a person's brain to save their life. And of course, then you start seeing things like military, things where it matters. A lot of people at our medical school embraced virtual reality before other people did. So I think that people don't embrace something unless they see that it's solving their problem. And it sometimes takes a long time after something can solve their problems. You and I have been working together with Anat Lubetsky at NYU for 7 years, going on 8 years, on using virtual reality to help people assess balance disorders and help them to get better balance. And we've been getting tremendous results, but it's very difficult to explain to people, hey, change the way you do things. And I'm not worried about it. I mean, it was, television was around technologically not that long after movies, but it took half a century before it culturally was like, okay, now we officially have television because now we understand what it's for and how to fit it into what a movie is, et cetera. So, I mean, I don't think we should rush these things. Everything sort of has its own rhythm. You should work on the good stuff and know that maybe not all the pieces are in place for it to be complementary to other things. It's like, hey, someone invented matrix theory, and it wasn't until a long time later that computers came around and, hey, we really, really could use that stuff. So I think it's fine to do research without looking over your shoulder and saying, is this going to be the commercial thing this year? I don't think we shouldn't be doing it that way. That's what industry does. We're academia. We're supposed to be inventing the future.
I'm responding to a question here as we still have some time for those to still put some questions in the Q&A. Are there aspects of your research that really zero in on human communication or advancing just communication in general? And that's slightly different than just collaboration, the communication aspect. And then even with that, what are some guiding principles that you've found in developing and experiencing XR?
Well, one of the things I think we've been inspired by is the fact that the unfortunate events of the last few years have forced us to meet a lot over Zoom. And we've realized that seeing each other's faces is actually very, very important to us. So I think that has discouraged us from doing research that focuses on synthetic avatars. I think we might have had more faith in that before, but now we really understand that the subtleties of, what's happening with someone's smile or their eyes or this or that, or, is so important. And so that's, at least for me, and I think the conversation with some of these students, it sort of changed our view of like what really is going to matter in the future. Did anyone else want to speak to this question? No, I guess not.
It's a question about kind of maybe you can hint towards the future of the lab. What's next? And I would ask potentially even if we can share the website of the lab here in the chat with people to definitely check out the other projects, several projects the lab has been doing for years. But maybe you can talk just a little bit, if you might, of what are you most excited about that's right on the horizon that you're taking a look at?
Well, we're not a lab in isolation. We have a lot of collaborators. There's Agnieszka Rydzyńska has this amazing spatial audio lab, and I'd mentioned Inaz Lubetsky with physical therapy, and Jan Plas and Bruce Homer who do learning and education, and Luc Dubois, who does accessibility, and the list goes on. Wynn Burleson at Arizona State, University of Arizona, and we find that it's really important to reach across the aisle and collaborate with people who have complementary skills and complementary reasons to think about why you do things. I think if we just stayed in our little comfortable computer science zone, we might be perfectly happy, but we might be solving problems that aren't really that relevant. And I also think the thing that Robert Ellis just said here, and I think it's Darcy Garbarg had said before that, the weird thing about COVID, as tragic as it is that starting on March 2020, people realized we can actually have meaningful interactions with people who are not in the same place. And I now have colleagues in China that I interact with multiple times a week. And I couldn't even have imagined that in February 2020. So, but we know Zoom isn't good enough. And that's what's driving a lot of what we're doing and a lot of other people are doing is we have to do better than Zoom. And we know that it's now possible to have real connections with people who for whatever reason cannot be in the same physical place.
As we're looking to almost close out our hour here, I want to end with this question about what you're looking forward to most. SIGGRAPH has continued over the past 2 years. I remind everyone, back in person for the first time in 2 years in Vancouver. So as we come back for the first time in person, what are you looking forward to most this year coming back?
Anyone else want to take on that?
I think that this answers both the previous question and this question, where I'd say just being able to see and talk with people in real life is it's just kind of the blanket cop-out answer here. I think that's what the greatest thing of going to a conference, like what that brings to the table. And in particular, I think talking with people and letting them try our project will drive exactly what the next directions of our research will be. So it's really important to engage with, people who are at the conference. That's kind of my answer. Anybody else want to?
To add on to Carl's points, as we develop a software or hardware, this tool, it's great to have a play testing and reflect and iterate the process. So we can expand our modules or expand, upgrade. And we know by fact that we'll have a variety of users, actual physical users that will be looking at our, looking at our tools. So I think that will be a great opportunity for being in person. So just having that play testing in real time.
Well, thank you so much for joining this webinar. A huge thank you to our panelists from the NYU Future Reality Lab for joining us today. For all of you who are listening, if you would like to listen to this presentation again, the recording will be up on our YouTube channel soon. And finally, don't forget to register for our SIGGRAPH 2022 conference so you can experience mixed reality collaboration in person, among another exciting other projects that'll be a part of the Immersive Pavilion selection for yourself. So again, NYU Future Reality Lab, I look forward to seeing you in Vancouver. Thank you so much for joining us, and thank everyone for logging in.